In 1951, a 31-year-old economist named Kenneth Arrow sat down and mathematically proved that no ranking system, not one, can ever be fully fair. Not tournaments, not elections, not any method humans have ever devised for taking individual preferences and turning them into a collective decision. Every single one is broken in some fundamental way. He called it the impossibility theorem and went on to win the Nobel Prize for it. So today, we are going to be looking at what this theorem is and how using it we can show why the World Cup tournament, or any other sport tournament in general, cannot be fair mathematically.
Okay, let's start simple. 3 football teams. Let's use 3 of the biggest teams this year: Spain, Argentina, and France. You want to know who's best. Simple enough, right? Just rank them. But here's the question. Who's ranking? The fans? The coaches? A panel of experts? FIFA's official ratings? Everyone has a different opinion. So you aggregate. You take all the individual opinions and combine them into one collective ranking. That's what every tournament bracket, every poll, every election is doing, taking many inputs, individual preferences, and producing a single output, a winner. Arrow's question was, can you do this in a way that's fair? And first, he had to define what fair actually means, because that's where it gets interesting. Arrow came up with 3 conditions, 3 common sense requirements that any fair ranking system should satisfy. They seem so obvious, so reasonable, that you'd be embarrassed if your system violated any of them.
Rule 1. If everyone agrees, the group agrees. This one's almost too simple to state. If every single voter, every single expert, every single fan thinks Spain is better than France, then the collective ranking should also put Spain above France. This is called unanimity, or the Pareto condition, named after the Italian economist Vilfredo Pareto. Seems fine. Obviously, a fair system should follow this rule. Rule 2. Irrelevant alternatives don't matter. Here's where it gets more subtle. Suppose your ranking puts Spain above Argentina. Now, a third team, France, gets knocked out of the tournament. Should that change whether Spain is above Argentina? Of course not. France's elimination is irrelevant to the question of Spain versus Argentina. A fair system should be immune to this. The relative ranking of any 2 options should depend only on how people feel about those 2 options, not on some third party entering or leaving the picture. Arrow called this independence of irrelevant alternatives. Rule 3. No dictator. The collective ranking shouldn't just be one person's personal preferences. There shouldn't be a single individual whose opinion automatically becomes the group's opinion, regardless of what everyone else thinks. This is non-dictatorship, a sensible requirement. We don't want the FIFA president's personal grudges determining the World Cup seedings. 3 rules: unanimity, independence of irrelevant alternatives, no dictatorship. All 3 seem obvious. All 3 seem necessary for any fair system. Arrow's theorem says you cannot have all 3, ever, simultaneously, for any ranking system with 3 or more options. Pick any 2, the third one breaks. To understand why this is true, we need to meet a French mathematician who spotted the crack in the foundation 150 years before Arrow, the Marquis de Condorcet, 18th century, revolutionary France. Condorcet was thinking about voting, specifically about how to aggregate people's preferences fairly, and he noticed something deeply unsettling.
Imagine 3 voters, call them a panel of football experts, ranking 3 teams: Spain, Argentina, France. Expert 1 ranks them Spain, then Argentina, then France. Expert 2 ranks them Argentina, then France, then Spain. Expert 3 ranks them France, then Spain, then Argentina. Now, let's ask, who does the group prefer? Spain versus Argentina. Expert 1 says Spain. Expert 2 says Argentina. Expert 3 says Spain. 2 out of 3, Spain wins. Argentina versus France. Expert 1 says Argentina. Expert 2 says Argentina. Expert 3 says France. 2 out of 3, Argentina wins. So far, so good. Spain beats Argentina. Argentina beats France. Logic says Spain should beat France. Let's check. France versus Spain. Expert 1 says Spain. Expert 2 says France. Expert 3 says France. 2 out of 3, France wins.
Stop. Let it sink in. Spain beats Argentina. Argentina beats France. France beats Spain. There is no winner. The ranking is circular. It goes around forever. No individual has a circular preference.
Every individual is perfectly rational, but the group's aggregated preference is irrational. It violates basic transitivity. This is Condorcet's paradox. And this is exactly what Arrow formalized. He took Condorcet's paradox and built an entire mathematical proof around it. The proof says, if your system always produces a winner, if it avoids the cycle, then it must violate either independence of relevant alternatives or it must be a dictatorship. There's no third option.
So, taking all of this into consideration, can we say that FIFA's ranking system is unfair? Sure, but there is something very important we have yet to address: the World Cup. It is the biggest factor in deciding a team's ranking. For instance, one of the main reasons Argentina is ranked number 1 in the world is because of their win in the 2022 World Cup. So one can argue that the World Cup is a good indicator of ranking. But here is the thing: the World Cup itself has a lot of issues with its system too. Problem 1, path dependency. In a single elimination bracket, who you face and when is as important as how good you are. In the 2014 World Cup, Brazil and Germany were both considered among the strongest teams. They met in the semifinal. Germany won 7-1, the most famous scoreline in World Cup history. Germany went on to win the whole tournament. But what if they'd been on opposite sides of the bracket and met in the final instead? Different game, different result maybe? The bracket shape determined the matchup, and the matchup may have determined the champion. The format produced a winner, but not necessarily the best team, just the best team on that particular path. Problem 2, seeding is circular. To make brackets fair, tournaments seed teams, placing stronger teams so they only meet weaker teams in early rounds. But seeding is based on rankings, and as we've just seen, collective rankings can be circular. You're using a broken input to design a fair output. It doesn't work. Problem 3, group stage arithmetic. In the World Cup group stage, teams get points. 3 for a win, 1 for a draw. Ties are broken by goal difference, then goals scored. This seems objective, but it creates absurd incentives. A team might deliberately lose a group stage match, it's happened, to avoid a more dangerous opponent in the knockout round. The incentive structure produced by the format actually rewards losing. South Korea and Indonesia were famously disqualified from the 2012 Olympics badminton tournament for deliberately trying to lose matches. Okay, I want to step back because this goes way beyond sport. Arrow's theorem is fundamentally about voting, about how democracies make collective decisions, and it says something uncomfortable. There is no perfect voting system. First past the post, the system used in the UK and US, violates independence of irrelevant alternatives catastrophically. A third-party candidate entering a race can split the vote and hand victory to the candidate that most voters actually like least. This is called the spoiler effect. Ranked choice voting fixes some of this, but it creates other problems. It can violate what's called monotonicity, meaning ranking your preferred candidate higher can sometimes cause them to lose. Kenneth Arrow proved his theorem in 1951 as part of his doctoral dissertation. His advisor, apparently, told him the result was too surprising to be true, that he must have made an error. He hadn't. He won the Nobel Prize in economics in 1972. At 51, he became the youngest person ever to receive it at the time. What I find remarkable about this result is its scope. Arrow wasn't just talking about football. He wasn't just talking about elections. He was making a statement about the fundamental limits of collective rationality. Groups of rational individuals can produce collectively irrational outcomes. Not sometimes, not in edge cases, structurally, inevitably. And this has implications far beyond sport and politics. Supply chains, committee decisions, how companies rank job candidates, how courts weigh multiple criteria for sentencing. Anytime multiple preferences or values need to be aggregated into a single decision, Arrow's ghost is in the room.